Testing 3, 2, 1. Okay, that's live. Oh, fuck me. Okay, now properly back. So, welcome everyone. This is for the part 1 assignment for CS4222. First assignment of the year and probably first stream of the year. Okay. Voice a little louder. There we go. So, Dermot starts us off with a few small things, such as what it should look like to begin with. So, blank project, I'm going to be doing part 1, 2, 3, 4, 5 when times come to it. So, new Java class image, and yes, I do want that again. So, image. So this is what Dermot has given us. I'm just gonna compact it down a tad because I don't like to waste space. So we can already see to begin with, and we have pixels, which is where we're storing the information on the image. Turn that down a tad. Don't need to be over my own mental voice anyway. So pixels, when we're storing the pixels, it's private because we don't want to leak it out. We'll probably create a method to return it if required. In fact, it's part of what we have to do. The other part is the width is being set and the height is being set. These are shortcut variables and they make the assumption that it is a regular array, that the width will be constant no matter what we send into it. It's a good assumption, and so let's go with that. So part 1 is we need to, well, before that actually, time to go to the resources tab, because he has actually given us a driver. See, image driver.java. Copy on that. Let's go back there, and I'm going to create a new Java class, image driver drmod, and yeah, got a rename file. Just need to catch the name because I'm a lazy bugger. And I'm gonna drop that down there. So this is the driver that he gave us. Are you there? Out of curiosity, who are you in the Discord? But yeah, Dermot's image driver here. We will be using it, and I will talk about how it's not perfect for testing all cases and why we have to do it. You can also see that some methods haven't been created on the image one yet. See in red there. Anyway, back to image. And so, what do we have to do? We have to do a toString method with the following header. So when we call toString, it turns it into a string. Fairly simple. And again, if I'm going too fast, please let me know. Public string, which is what we're returning to string, and this takes no arguments, but we can go the real complicated way of looping through the array and adding everything to a string and spitting it out, which is pretty good, and I do recommend you would do that sometime in the future, but not for this. what we're going to use is what Dermot himself is using. On his driver, there's arrays deep to string. And it means that whenever we test it, return, it will spit out the same thing that his driver is expecting. And what I want is I want the pixels. So when you call to string, it's gonna grab whatever's in pixels and just do this conversion. I've got no idea how it does it. I don't need to know. I know it just does. Let's throw an underscore first, essentially. So, new line for that, and what's the next one? So, flip. Flip horizontal. Well, flip, and then... So, what this... Hey, can you actually hear me fine? If it's still there. Flip is the first one that is changing pixels. So for this we need to do a if flip. If, not flip, I bloody did. If horizontal. Oh, let's do something else. So the reason why I'm not doing if horizontal equals true is because horizontal is a boolean. It is already true or false. So evaluating if true is true always will give out true. Same way that evaluating false equals true will always spit out false. We've kind of done that in ET before. But where are we at? There we go. So, did your connection drop out or something? Okay, there I go back. So, how does Dermot expect to do the horizontal? So horizontal is just flipping back to front. So we keep the rows in the same position and we flip the cells back and forth. So we need to go into each individual row. So for int I equals 0, so start on the first one. I is less than height. I plus plus. So I in this case will be the row. Let's just explicitly name it that way. If so, for row is 0. Yep, that's it. So for rows less than the height, continue on. And then what we want to do next is what's it again? So we go into the row and then we flip the cells left and right. So another loop in it for column. Col is less than the width. The interesting thing about this is we don't need to go all the way through, because if we start started the first column, flip all the way through, we'll have flipped things correct way, and then we'll have flipped it back. So we need to go halfway. So because we're exchanging positions, we're going to need a temp name. So because if you have a pixel and strip out the outer layer, and you've got an array of ints, and if you strip out the inner one, you now have an int. So each cell essentially is an int. So it's int t equals the pixels row col. So this is the temp value, we're storing it, and in where am I going again? Yes, so we know that in row and col, that's the value we want to have, but we want to find its one on the other side. So int mer feck is equals to the width minus 1 minus I not there. So oh no, col. So we come back 1 because we do not want to be at the end of it. Remember, off by 1 errors, and then we subtract position. There we go. And we take off the column because that's how many row columns in we are. So what I'm going to do is take this, which is the current row that we're on and the current col, and instead we're going to set it equals to what's in its partner. Equals, except it's not the col, it's the friend of the col. And now we go here, colmer is equal to 10. I'm just gonna move that down so it's all together. So this is out its partner. Move its counterpart and swap things. Swap things around. Okay. Flip. And this. Oh, it's giving another rotate. So if you need to test stuff before you are finished implementing on the members, you can put in dummy stuff. So if I go back here and I pop in this, it's gonna do nothing because we've literally got no code in it, but it's gonna allow us to run this particular script argument. So where are we going? Yes, so see here, flip horizontal. Original image is this. What it expects to, what we got as a result of it was this, which is good, and it's exactly what we expected to see here. So you can see it matches the ones above, and the second one matches the third. In this way, I do like Dermot's driver. It is quite good because it does show you what you have, what you changed it to, and what you had, yeah, that one, what you changed it to, and what you expect to get. Of course, you can see here that the flip vertical is not there yet, but we're going to get around to that just now. So that is done. I'm actually going to use a very similar structure for the other sided flip, the horizontal flip. Else, there we go. Except this time, we don't need to go nestled into it. We only need to swap the rows. So, in this case, let's go here. We only need to go down half the height of it, so that by 2, and the column row, well, row row. Let's just quickly change that out. Refactor, rename. There we go. So that is the height minus 1 minus the row. And so temp this time, if you notice, if I just take off the row con part at the end, it's gonna give an error. You know why? Because I've got the type as an int, but realistically it is a array of ints, because remember we're doing with 2D arrays within arrays. So the temp value is this, and take that off, take that off, take that off, and boom. So we've saved the row we're on. We're setting row to be whatever its mirrored one is, and we're setting the mirrored one to be what was saved in the temp. You can clearly see that because we're swapping rows, we don't need a loop, but we do need a different temp value. Oui, I'm not French. There we go. And you can see typos come naturally to me. And if we run this again through Dermot's driver, we will see, come on, compile, there we go. So, flip horizontal works, flip vertical works. It is perfectly grand. I'm just gonna save that there. Oops, I'm not searching. Feet. Saved. And need to capital name him. Commit. And now save this. So feet is short for feature. Flip complete. Yes, it is. Warnings. Yeah, ignore those anyway for the moment. Excuse me. Ouch. So yeah, now rotate. Rotate is where people have had issues, and for good reason. Long story short is Dermot's driver here doesn't count the entire picture. His one only rotates once, then resets. Then test rotating the other way, which is good and grand, but you do need to rotate it at least twice to get the full proper expectation. So I'm actually gonna take a peek at my own code again because oh, good. So rotate. Basically, for rotating, we take a array of, say, array which is 1, 2, 3, and we turn it into array of 1, an array of 2, and an array of 3. Well, let's give it another row just to make it kind of clear what's happening. Give it a comma there, and it is 3, 4, no, 4, 5, 6. 4, 5, 6. 1, 2. So it's turn it. It's 4, 1, 4, 1. Then it is 5, 2, and 6, 3. And so, yeah. So the way we do it is we create a new array, and we know the final size of it, which is good because we can use an array then. So it's int, same type as pixels, is equal, pixel new is equals to new int, and it is, so I'm gonna close you up because we don't need to see you again, or you. So we know height in the original is the first one, the outer, and it's the inner, these widths. But in our one, they're getting reversed. Width is now height, and height is now width. Hey, Aaron. Yeah. I like good music while I'm doing code. It does raise stakes slightly. But makes it fun. So, now we need to loop through. Well, actually, first we need to figure out are we going clockwise or anti-clockwise. So, if, like above, clockwise, do blah blah blah, else we do else, which can understand that. So we have our new array here. Fortunately, even if we're going clockwise or anti-clockwise, it will be the exact same shape. And normally when you create an array, they're filled with zeros. For int, it's filled with zeros. We don't really need to care about that because we are not doing that. We're literally copying values from one array to another. So let's loop through. I'm gonna borrow my code from here, and yeah, I borrow a pile of code. So for row is that, and call, yeah, we're not going through there. So there are gonna be no temps. I'm just gonna bring you up because okay, so where did I do it on paper? Okay, so this one here, 0, 0, went into 0, 1. 2, which was 0, 2, went into 2, 0. two actually. So yeah, row is. Yeah, I definitely need to pull up my own assignment. Project 2. Wait, no, this is this one. So ignore me open it in the background. So, did I do it again? It is. Wait, what is? Oh, the review. That was as good as why I saw the. So flip, very easy to do. So it's oh yeah, where I have it. So we update Pixon's new. Pixon's new is equal to this here. So whatever current row we're working on in the original, we need to find out what place it goes into the final result. Now we are quite lucky because remember that the width and height are flipped around. We can literally just use the inner one of col first, because that will be where you expect it to go. See, it's flipped from here to here, but we need to give it a new height. Remember what we did up here with the mirror value? The same is actually pretty much true with the new value here. So it's, if you think about it, it is height. We're setting the new height based on the own values. Well, can't remember. What was height is now width. So remember, you're rotating it. You can't really see my hands on camera, but I'm rotating my hands here. So it's height. Now we need to beware of the off by 1, which is -1. Oh, not minus, just 1. And we also need to subtract, like up here, the row, because when we're dealing with height, we're dealing with row. And there, that should give us the proper clockwise motion. And let me just copy this down to the out. And the thing about the else, rather the anti-clockwise, is it is going in the opposite direction. So let me just comment this out, or at least clear it out. So we are setting the new row. So row will be what we match over here, but it is the width that we take care of, -1 and minus col. You can see the similarities between these two here. When we're going right, which is clockwise, we are updating the col with the current col, but we are changing the equivalent height. It's flipping things around in a way that makes sense. Sorry, it's difficult to explain it too well. So yeah, that's got it flipped around. However, we need to update the values, and so this dot pixels is equal to pixels.new. And see here, if I actually comment this out, you can see it clearly. But see here, pixels here, my IDE is telling me pixels may be final. And final means a constant, unchanging. But because we are literally updating it here, it goes, oh, that doesn't apply anymore. So work with that. I'm going to move that because I may confuse otherwise. And not only do we have to update pixels, but remember that we now have a new height and width. So we need to go int height new is equals to the width. So what was width will now be height. And I'm going to do the exact same with the width as well. Int width new is equal to height. No, not height. It's height. There we go. And we need to set these as well. So this dot height is equal to height new. This dot width is equal to width dot new. And that should be perfectly fine for us. Let's go back to Dermot's driver and run it. Run it. Don't need to pick one. So you can see that the rotations, what you give it originally, what you got out, and what you expect to see, all work fine, which is good. We have basically everything that Dermot's driver has gotten us to do. So it's just let me just save that there. Feet. Rotate complete. This on its own will get you the most of the marks. You can see here that here's one. Let's see. Let's just show this here by example. Even if we don't update the height and width, Dermot's driver will still give us the 22 out of 22. See, 22 out of 22, and we're not updating the height and width at all. This is the trap of using his one. I kind of suspect that he's put this in here on purpose because it's a good thing to learn, that your tests may not be comprehensive. So let's undo that and make it work nice. So now, because Dermot's one has flaws, we need to create our own image driver, which would be image driver edit. I did that back up. Wait. Fat-fingered stuff. There we go. So, again, how did I do it on my own? Okay, so main. IntelliJ is lovely. It can automate some of the laborious things, like I just press M and it goes, hey, do you want to start the main function? I press enter and it goes, boom, there you go, have a nice day. So, I'm gonna copy this from my own example, which is I have a 2D array here, which is int a photo is just an Excel sheet, and anyone is ever curious about what that is, I'm actually going to pop the link in chat, and it is Steve Mond and spreadsheet. Steve Mond, isn't it? Yeah, it is. Comedy stand-up routine about spreadsheets. Well worth the view because it goes into the reasons why, probably why the chose to use image as the name of the thing we're doing. So spread that out nicely so it's readable. So this is our example image. It's tiny, I know, only 3 pixels by 2 pixels, but it's good enough for our purposes. So what we want to do is go picture, image, which is the type, picture is equal to image dot new image, new, oh wait, lowercase, new image, pop in the semicolons at the end, and it's the photo is just an Excel sheet. And so that gives us the class that we just worked on here, and shoves in the 2D array, and now we've got a picture which we can manipulate. And so let's just print it out. System.out print line, and it's picture dot to string. Oh wait, that's grayed out. Why is that grayed out? So let's just run image driver. So it will be as you expect. First line is 1, 2, 3. Second line is 4, 5, 6. But this is grey. And if we hover over it in IntelliJ, it tells us why. Unnecessary toString call. And the reasoning why is actually something we're doing at Michael at the moment. When we call print line, it's gonna see can the object be coerced into a format that can be printed out, which is a string. And so it looks and finds toString method, which is what it wants. And so if we go and run that again, we're going to see that it's actually going to run fine. And for prosperity, I'm just going to make sure that one is in there anyway. So, and for double measure, I'm just going to explain automatically pawns the toString method, which is what we want. Explain why. So that is the first line done out, which is good, what we want. So we want to rotate it. So it's a picture dot rotate. Now, as we talked about, the flaw in Dermot's one is that you cannot chain them together. And just to actually show you, if you look at Dermot's setup, he has it so that when you're rotating it clockwise, it compares it, and then you create a new selfie afterwards, so it resets it essentially. I'm not going to give my own one an option of that here, so it's true. So rotate it clockwise once, twice, 3 times. 3 times should be enough. Now let's print it out again. Should be a long boy. Now it should be 1, 2, and 3 times out. So yeah, you can see that what was at the end is now at the top. So 3, 6, 3, 6, 2, 5, 2, 5, 1, 4, 1, 4. And for good measure, let's undo it anti-clockwise once, anti-clockwise once, and let's see what it looks like again. Now the end goal I'm doing of all these tests is I'm going to run it through the gauntlet of all the methods and the options of those methods. So we have back to image, oops. So we have created 3 methods. We've got toString, we've got flip, which accepts a boolean, so you have to go through both the true and false flip. You've got rotate, which accepts a boolean, so you again have to go through true and false. So we're just going to go through all of them, test them out, and make sure things are fine. So the 4th one should be upside down, which is kind of what you expect. So if you take this, you turn it twice, it should be upside down, which is this one here. This one here. So it's 1, 2, 3, 4, 5, 6, almost like completely backwards. So that's rotation sorted out, and what about flipping it? So if we do, say, picture dot flip, and how about we go fonts first, which means we are going flip it upside down again, and take a look at it. So in this one, remember this, so next time round it should be 3, 2, 1 in the first array, then 6, 5, 4, and yeah, 3, 2, 1, 6, 5, 4, which is close enough. And you know about that? What if we just flip things around again? But instead of horizontally, we're going vertically. True. And printing out again. So, oh no, I do not want to go to documentation itself. Thank you so much for that. So, this should, if we've done all our work right, flip it back into this format here, the original format. Yeah, so you can see here at the very beginning when we print out, it's 1, 2, 3, 4, 5, 6, and now we're back to that again. It took a couple of operations, but you can see how flipping back and forth works as well as rotating. Have you any questions on that? Hey, can you see if anyone here? If you're here, speak up in Discord or something. Yeah, no questions. Heck, not even sure if anyone's here. But there we go. This should get pretty close to full marks. Oh, almost. So let's just save that as the drive. But that's not full marks. Let's see. Why is that? Oh yeah, unnecessary. That's fine. For full marks, we need to do one more thing on the two files. So it's you need to add a comment at the top which says, again, what's the format that I did myself? ID. 1 2 1 3 3 6 8 9 1. It is your ID, your name, Brendan Gordon, your module for good measure, CS4222, the date, because it's always a good idea to have on writing when you've got things completed. It's not, again, not required, so it's a 2022-02 dash, what date is today? Today is the 27th. And that may sound like a weird date format to you. ISO 1 date. What's the date from the date? Oh, it's 8601. The date format is let me just put it in a new multi-line comment. No, not that, I need this. Date format is ISO 8601. And if you want the full Wikipedia page of it, it is here. The long story short of it is that it goes most significant numbers first. So year first, then month, then day. And it also has T for time, and then hours, minutes, seconds, milliseconds, and then time zone. It's incredibly useful because it's a very good way of organizing a name or something in a way that a machine can alphabetically organize it. It's convenient if you get used to it. Can be a bit to get used to though. So we take this and we shove it into all our files. You know why? Because unless we have them marked in, he is gonna dock us. And I'm just for good measure gonna pop it in Diarmuid's version as well. And there we go. Let's save that up and we can complete. Added personal information. There we go. Commit anyway. And yeah. So, in case any of you were wondering where I've just pushed after, it is gitlab.com. I'm just gonna pop the link in here. Tutorials, 222, and there we go. Yeah, here we go. Wrong place. Too many windows. And with that, I am gonna end. Unless you've only got anything to talk about. And grand. Well, farewell then.